U.S. Navy sailors spend the vast majority of their time at sea inside the steel walls of an aircraft carrier or destroyer. But occasionally, a crew will organize what's known as a swim call. They drop anchor, open the hatches, and let personnel take a refreshing dip right in the middle of the ocean. While it looks like a giant, relaxing water park, putting a large portion of a ship's crew into the water creates a massive operational vulnerability. With dozens of sailors swimming around the hull, the ship's defenses are temporarily compromised, and the swimmers themselves are entirely exposed to the elements. That exposure became a very real problem in 2020. During a routine swim call in the Pacific, Coast Guard members spotted an 8-foot shark closing in fast on the vulnerable crew. The ocean is an environment hostile to human life. Operating safely out here means planners have to break down the specific dangers of the sea and engineer exact protocols to counter every single one. The most immediate, visible threat to personnel in the water is marine predators. To mitigate this risk, the military relies on a strict protocol of armed overwatch. During every swim call, designated lookouts and maritime enforcement specialists forfeit their own recreation time. They stand guard on the deck, rifles loaded, and aimed squarely at the water, continuously scanning for movement. When that 8-foot shark approached the Coast Guard crew in 2020, the guard on duty didn't hesitate. They fired a burst of well-placed shots directly into the water, right in the shark's path. Gunfire impacting the surface of the ocean acts as a massive sonic deterrent. The loud, concussive pressure waves overwhelm the shark's highly sensitive navigation systems and scramble its forward path. That sudden burst of kinetic force creates immediate confusion, buying the crucial seconds needed for the swimmers to scramble up the nets and back to the safety of the hull before a strike occurs. But the most pervasive danger of the sea is extreme isolation. If someone suffers a severe injury or falls critically ill hundreds of miles from the nearest port, a simple ladder won't help. That requires a medical evacuation. Launching a rescue helicopter over the open ocean is highly risky, so commanders rely on a strict launch checklist. A flight is typically authorized only if a patient faces imminent risk to life, limb, or eyesight. Before a rotor even spins up, Coast Guard flight surgeons and pilots run complex calculations. They measure the offshore distance against the aircraft's exact fuel capacity and weigh that against the current visibility to ensure the rescue team doesn't become stranded themselves. When the conditions are cleared, they dispatch the MH-65 Dolphin. This twin-engine helicopter is the primary tool used for offshore extractions. The Dolphin uses an automatic flight control system to hold the aircraft in a stable hover 50 feet above a target. In pitch-black darkness or heavy storms, human pilots lose visual references, but the computer maintains exact spatial coordinates. With the aircraft perfectly stabilized above the vessel, the crew locates a clear area near the aft, away from the smokestacks. They then carefully lower a basket, secure the injured patient, and winch them up. Overcoming the ocean's severe isolation relies heavily on removing human error from the flight equation. By automating the most dangerous variables of the hover, the rescue crew can focus all of their attention on the physical extraction and care of the patient. Even with advanced automation, flying over water remains inherently dangerous. If a mechanical failure occurs, the rescue helicopter itself could plunge directly into the sea. To prevent rescuers from becoming casualties themselves, the military mandates rigorous underwater survival conditioning, specifically known as shallow water egress training. Inside specialized training pools in Savannah, Georgia, Coast Guard crews practice this exact scenario. Students are strapped into a metal frame replicating the tight dimensions of a helicopter cockpit. Once strapped in, the frame is dropped into the pool and violently flipped completely upside down, trapping the personnel underwater in a tight enclosure. The disorientation is immediate. The crew members have to suppress their natural panic, locate and activate their emergency air supplies, unbuckle their harnesses, and systematically maneuver out of the submerged capsule. Mastering this specific egress technique is so critical to open water survival that NASA astronauts run through identical drills to prepare for the risks of an ocean splashdown. This training highlights a core reality of working at sea. Millions of dollars in rescue technology are useless if the human operators cannot survive a sudden, catastrophic immersion in the water. The military operates with the clear understanding that they will never conquer the ocean. They drill for massive worst-case scenarios, participating in exercises like Cascadia Rising, which simulates the chaotic response to a magnitude 9.0 earthquake and the massive tsunamis that follow. Personnel are trained to recognize a wide, constant spectrum of aquatic threats. A single deployment might require identifying rip currents, mitigating rapid hypothermia, or dodging towering swells. Safety at sea requires tightly layered preparation, combining the blunt force of armed overwatch with precision aerospace automation and grueling physical conditioning. By breaking down the individual threats of the environment, sailors and rescue crews avoid being paralyzed by the danger of the open water. They carry the exact tools and training required to respect the ocean, survive its worst conditions, and complete their mission.